Now tan x plus y is equal to tan x plus tan y divided by 1 minus tan x tan y. Looks tricky, right? Just take the left hand side. Tan x plus y can be written as sin x plus y divided by cos x plus y. Sin x plus y is sin x cos y plus cos x sin y. We also know cos x plus y is cos x cos y minus sin x sin y. Now look at what we need. We need tan x plus tan y on top. So how do you make this as tan x? We can do that by dividing it by, let's see, sin x cos y. Sin x cos y, if we divide it by cos x, we get tan x. But we also have cos y. Now that should get cancelled. So we divide it by another cos, that is cos y. So now this will get cancelled and we will be left with, so we have to divide it by cos x cos y. So sin x cos y divided by cos x cos y. Now we do this for all the terms. So cos x sin y divided by cos x cos y. Then take the denominator, cos x cos y divided by cos x cos y minus sin x sin y divided by cos x cos y. Now see what all gets cancelled. This gets cancelled, cos x gets cancelled, cos x cos y. Here nothing gets cancelled. Okay, so sin x by cos x is tan x plus sin y by cos y is tan y, and then this is 1 minus sin x by cos x is tan x cos y. Yes, which is what we had to prove. But remember, in this identity, what is important is that the denominator cannot be 0. Yes, denominator cannot be 0. So which means that x, y and x plus y cannot be equal to odd multiple of pi by 2. Why? Because tan x is nothing but sin x by cos x, which means cos x cannot be equal to 0, and cos x is 0 when x equal to pi by 2. Yes, 5 pi by 2. So basically odd multiple of pi by 2, even in the negative direction. So this condition you have to mention, or you have to remember it whenever you are applying. Okay, let's look at the next one. Let's say 17th. The same identity with subtraction, tan x minus y is equal to tan x minus tan y by 1 plus tan x tan y. Now take the previous identity, or you can do it the long way, but short way of doing it is tan x plus minus y. We know this identity, tan x plus tan y divided by, now here y, instead of y, take it as minus y, and 1 minus tan x tan minus y. Now tan x, tan minus y is minus tan y divided by 1 minus, now this tan minus y is minus tan y, so minus into minus plus, so tan x tan y. Now here in this case again the same condition applies, x, y and x plus y cannot be odd multiples of pi by 2 to avoid having the denominator as 0. Okay, let's look at cot. Cot x plus y is equal to cot x cot y minus 1 divided by cot y plus cot x. So now cot can be written as cos x plus y by cot x plus y by sin x plus y. Yes, we know cos x plus y, cos x cos y minus sin x sin y. We also know sin x plus y is sin x cos y plus cos x sin y. Now this should become cot. So for this to become cot x cot y, see, if this has to become cot x cot y, we have to divide it by sin x sin y. Yes, so cos x cos y divided by sin x sin y minus sin x sin y divided by sin x sin y. Now we have to divide all of them also by sin x sin y. Now this nothing gets cancelled here, sin x gets cancelled, sin y gets cancelled, so you're left with 1. Sin x gets cancelled, sin y gets cancelled, so which is now cos x by sin x is cot x cot y minus 1 divided by cot y minus cot x. Now here again x, y and x plus y cannot be multiples of pi. Why? Because cot is cos by sin, so sin cannot be equal to 0, and sin will be equal to 0 when the angle is multiples of pi. Okay, next cot x plus y we have seen, so x minus y becomes easy for us. Cot x cot y minus 1 by cot y minus cot x. So cot x, we use the previous identity itself. yes, can be written as cot x plus minus y. Okay, so this can be written as cot x cot minus y minus 1 by cot minus y minus cot x. Cot x minus y, this should be plus and this is minus. Okay, now here cot x cot minus y is cot y. Okay, we seem to be ending up with the same because this will be cot x. No, I made a mistake here. See, this is plus, so this should be, denominator should be plus, which means that this should be plus. Okay, okay, be careful of this type of mistakes. So which means this is plus. Now cot minus y is minus cot y, so this is minus cot y minus 1 by minus cot y plus cot x. Now let's take minus out. If we take minus out, cot x cot y plus 1 divided by, and denominator also we take minus out, so we get cot y minus cot x. So minus minus gets cancelled, so we are left with cot x cot y plus 1 divided by cot y minus cot x. Now here again x, y and x plus y cannot be equal to multiples of pi. So let's look at the next one. Very interesting. Cos 2x, right? Cos 2x. We can end up with multiple identities. So remember, this can be written as cos x plus x. We know the identity. Cos x is cos x cos y. So here y is also x minus sin x sin y. So which means this can be written as cos square x minus sin square x. Yes, so cos 2x is equal to cos square x minus sin square x. This is 1. Now cos 2x, now we can take this further. We can write cos square x as 1 minus sin square x minus sin square x, which is 1 minus 2 sin square x. So this is the second identity within this. Again we take cos square x minus sin square x, that is the first one, and we do the same thing with respect to sin square x. So cos square x minus 1 minus cos square x. So cos square x minus 1 plus cos square x. So 2 cos square x minus 1. So this is the third identity. Again we take cos square x minus sin square x and we divide it by cos square x plus sin square x. Right? Remember, this is nothing but, the denominator is nothing but 1. So it is perfectly permissible divided by 1. Okay, now all the terms we divided by cos square x. So cos square x divided by cos square x minus sin square x divided by cos square x sin square x by cos square x. this gets cancelled, this gets cancelled. So we end up with 1 minus tan square x by 1 minus tan square x. Sorry, here it is plus, here it is plus. So this is fourth identity. Okay, let's take the next one. Next one is 21. Sine 2x, 2 sin x cos x. Okay, and this is also equal to 2 tan x by 1 plus tan square x. Now let's see how that comes. Now remember, sine 2x can be written as x plus x. Now we know sin x plus y is sin x cos x plus cos x sin x. Identity wise, it is actually sin x plus y equal to sin x cos y plus cos x sin y. But since here y is also x, this is what it comes to. So they both are same. So 2 sin x cos x. Okay. Now this is the first one. Second is we divide it by cos square x plus sin square x. This is again, remember, is 1. Okay, denominator is actually 1, so we are dividing it by 1. Now we want to end up with tan x. Remember, we have to prove that it is equal to tan x, 2 tan x by 1 plus tan square x. 2 is already there, so what we require is tan x. So tan x is, so we require to divide the numerator by cos x, and to cancel the second cos x we require another cos x. So 2 sin x cos x divided by cos square x, the whole thing divided by denominator also, cos square x by cos square x plus sin square x by cos square x. Now remember, one of the cos x will get struck off, cancelled, so we'll end up with sin x by cos x, which is tan x. Here these two gets cancelled. Sin square x by cos square x will be tan square x, which is what we needed. Tan 2x is equal to 2 tan x by 1 minus tan square x. Okay, remember again, tan 2x can be written as tan x plus x. We have already seen what is tan x plus y. Yes, tan x plus y is this. So tan, no, this is cot. Oh, we have covered lot of ground. Tan x plus y is this. So tan x plus tan y by 1 minus tan x. Tan x, see, this should be tan y. So that is why when you do a problem, review it. Sometimes you'll think something and write something, just like I did. So tan x plus y is tan x plus tan y by 1 minus tan x tan y. Tan x plus tan y by 1 minus tan x tan y. Be careful, it should look like tan y. Okay, now here y is x, so we convert it into x, so which becomes 2 tan x by 1 minus tan square x. Okay, we have covered a lot of ground. Now practice. Bye for now.